Hello everyone. In the last session we have started about OS, what is OS and the goals of an OS and the different features we need to consider when we are selecting an OS. In this session let's discuss about the operation of an OS. We said OS is a software which helps us to achieve a particular task, right? Now we say that the basic function of an OS is to check out how a program has to be executed, how to allocate the available resources, and it has to prevent the interference with programs and resources. Based on these things, we can say that the key concern of an OS are how to allocate the resources to the programs, how you can schedule the resource, and how you can protect your data, right? So you can see the key concerns over here. We are saying the concerns are programs. With respect to programs, your OS responsibility is to check out when it has to initiate and when it has to terminate the programs, and it has to provide the different methods so that the programs can work towards the common goal. Similarly, when it comes to the resources, so resources are nothing but the devices which are available, which makes our work to be done, right? So now you have to check out whether the resources are available. If it is so, how much they are available and how we can allocate them to the system and the different programs. Once it is done, allocation is done, then you can deallocate them, and again the same memory or the same resources can be used for different or any other program. So once you are allocating the resources, then we have to check out about scheduling also. So scheduling is nothing but you are giving your resource or you are giving your CPU to the particular program, and once it is done, you have to check out when you have to allocate that resource and how long you have to allocate the resource. Once it is done, your program execution is completed, then you can deallocate that resource and it can give into the next program. Next comes protection. So here the protection of your data and program is mainly important so that you can achieve privacy, right? We just want the OS to take care of your data and program so that it should not be interfered with other users and their programs. So these are the key concerns of your OS, where the key concerns are said as programs, resources, scheduling and protection. So programs is nothing but when you have to initiate and when you have to terminate, and you have to give the convenient method so that the programs can work towards a common goal. Next, resources and scheduling. What are the available resources? To which programs you need to allocate them, how long you have to allocate, and when you have to deallocate, and then we have to take care about the protection of data and programs. When we are switching on a computer, automatically it will invoke a procedure of loading a basic software into the memory of a computer, which we call it as bootstrapping. So bootstrapping is nothing but when you switch on your computer, automatically it will load a software into the memory, right? And once it is done, bootstrapping is done, then the OS will take care of loading of other software. Here the OS will also maintain the information, right? The information about the current status of resources and programs for use, right? Once the resources are allocated for a particular program, then OS has to take care what are the available resources right now and to which program we need to allocate them. It is not like permanently we are allocating. No, we have to allocate when it is needed and then we have to deallocate. So just now I said scheduling. So scheduling is nothing but you are providing sufficient CPU attention to a program's execution. So this is about the key concerns and how your OS has to take care of the things. Then comes what are the common tasks which are performed by OS. The common tasks are generally, we know all the things. It is like you have to we have to construct a list of all the resources available in the system, right? The first thing it has to do is it has to generate a list of all the resources which are available in the system. It will be performed when OS is started. Then the second task can be initiating execution of programs. You have to check out which program has to be executed when user is giving a command. Then you have to maintain a list of authorized users. It is not like anyone can access the resources. No, your user should be authorized and that list should be maintained by an OS. Therefore, it will be done when a user specifies which collaborators can access what programs or data. Similarly, you need to maintain, or an OS need to maintain the information for protection when you are registering new users. You have to perform scheduling. Scheduling is what? One of the tasks which says that when you have to, where you have to give your CPU to which program and how long you have to give, when it has to be during your OS operation, and it has to handle requests made by users and their programs when the user is requesting. So general, it has to maintain a list of all the resources, maintain a list of authorized users, it has to perform scheduling, it has to check out about the initiation and also the termination of the programs, and it has to request made by the user. So these are all the basic tasks which has to be performed by operating system. So the key concerns we said, program management we said, and then we said about resource allocation, protection, right? So now look at what is program management. So based on scheduling we said, so scheduling is what? Allocating your CPU for sufficient time, right? So here based on scheduling, your OS will decide which program should be given to the CPU. It is not like anybody can be used, anybody can use the CPU. No, it will be decided by the OS which program will be given the CPU and for how long it has to be given. Once that program is in execution, or once the program is using CPU, the OS may take back that program. You know, the program what it is executing, it can complete the execution, or it may be in the way of execution. If the OS wants, it can take back that program and put it in the sequential list again. That taking of the program may be on the request, or maybe it will forcefully take back, right? So scheduling is what? You are giving your CPU to a particular program so that it can make its work done. If the OS wants, it can take back the program after execution is completed, or even the execution is going on, right? Once it has been taken that program, it will put back into the list, where again that program will be in the waiting list to take out that CPU. So this phenomena is called as preemption. So preemption is what? Your program is in execution, the OS will take back that program and put it back into the list of waiting, where that list is of waiting is what? When it has to take back again CPU. So that phenomena we call it as preemption. So preemption, it makes that like again that program will be in the list, it has to wait for the list. So here you can see so we said, here you can see here. So I said no, the programs which are waiting for the CPU, it has been in the sequential list, it will be given to a scheduler. The scheduler will select which program has to be given to CPU. So the CPU, it will take out the program. Once the work is done, yes, program is completed. If not, the OS will take back that program. So that are nothing but your preempted programs, and again it will put back here. So that program will be again listed in list. This is the scheduling, where your program will be in always in the queue for using the CPU. So this method where your OS is taking back the program and putting back in the list is called as preemption. So next we have resource management and scheduling. We said that the available resources should be allocated to the particular programs, and once you are allocating, again you have to take it back, right, so that you can give it to some other program. Here there are two kinds for the allocation, resource allocation. One is partitioning of resource, and the second one is allocation from a pool. So partitioning of resources means the available resources are equally divided to all the programs. Whether you need it or you don't want it, it will be simply allocated to all the programs, and that simply allocation is called as static allocation. But here, even it is not needed, we are allocating equally the available resource to all the programs, there comes the wastage of resource. The problem is wastage of resource. And the second is allocation from a pool. So allocation from a pool says that the resource will be allocated only when it is needed, and a program has to request that it is needed, it is in need of some resources, then only you will allocate the resources. So that is called as dynamic allocation. You can look at here. So this is a diagram for your partitioning, and this is for your pool. So here partitioning says that every program is say equally allocated all the resources. You can see here we have a 1 MB of memory, you have a disk, and you have a monitor. So this has been given to different programs. They may use or they may not use. If they are using, then it is effective utilization of resource. Okay, fine, done. If they are not using, there comes the wastage of resources. To come out of that problem, we go for pool. So here what is happening, based on the request given by programs, we will allocate the resources. You can see here program P1, it is requested for a monitor, for a disk, and for a memory of 1 MB, whereas program P2 has been requested for a monitor and 2 MB of memory. Right, whatever they have requested, only that much it will be allocated, whereas in partitioning, what we are doing, the available resources we are simply allocating. They may use or they may not use. That is where the resources has been wasted. So when we come for simple resource allocation, the resource allocation is based on resource table, which is easy for us to have an overview, like which are the resources are available, are they free, are they allocated. So that we will maintain a table. So that a table we call it as resource allocation table. Here we will make out a list, like what are the resources available, to which class they belong to, what is the address we have given them, and what is the status of that resource. For example, you can see here we have taken a printer 1. The class of that resource is printer. The available address or the allocated address for this is 101, and status is yes, it is allocated to program P1. Similarly, we have printer 2. Of course, it belongs to a class printer. The address we have assigned is 102 and the status is free. That means that this printer or this resource can be allocated to any other program. Similarly, printer 3, you can see disk 1, class is disk. The address it has allocated is 201. Of course, it is allocated to program P1. Similarly, disk 2 is allocated to program P2, and CDW1, nothing but CD writer, and it is free, therefore it can be allocated to any other program. Again, the sharing of resource your programs can be done in two ways. One is sequential sharing and the other one is concurrent sharing. So sequential sharing means when you are allocating a resource to a particular program, once the work is done, then only you will deallocate. You will deallocate, again the same resource will be given to some other. Right, it is like one after the other. You have taken one resource, for example, you have taken printer, you have given to program P1, printer 1, program P1. Once this function is done, then only you will take printer 1 and it will give to some other program. Whereas in concurrent sharing, more than 2 programs can access the same resource. For example, you have printer P1. This printer P1 will be accessed by program P1 and program P2 simultaneously. So if you are using more than one program is using the same resource simultaneously, then it is called as concurrent sharing. If you are using one at a time, or nothing but once you are allocating and you are waiting for the function to be done, and after it is done, then you will deallocate and it will give to some other program, that is called as sequential sharing. And then comes CPU sharing, nothing but your scheduling we have discussed. And the last we have is virtual resources. So we all know what is the meaning of virtual. So virtual is something like it is existing but we cannot see. It is an illusion but not an imagination. So here the resources what are available, it can be even created as virtual by the operating system, so that the resources can be used effectively and in more number by the users. For example, you have memory, so that memory we can even create as a virtual memory, where your physical memory will be mapped. The existing memory, now what we have real memory or physical memory, it will be mapped into logical, where that logical or virtual memory will be more compared to real memory. Similarly, the available resources are also created in the form of virtual, so that the users will think that yes, available resources are more and they can access more programs or more resources and more information, right? So we'll end up with this session.